Hi, my name is Doug Vogt from the Dial Foundation, and it's been 2.5 months since my last video, and it's because the amount of research I had to do for this particular video, which I think you'll enjoy and you're going to learn a lot. What I'm going to cover is the different names given for a stellar nova, and there's a reason why. I'm going to explain it. The different databases of stars I had to research to prove my point without question. VIII mono compared to other novas and planetary nebula, you'll see what I mean and why they thought this was a light echo and all the others were not. Government deception or why they did it. Okay. The philosophy obviously comes from this book, Theory of Multidimensional Reality, and God's Judgement, written 12 years ago. Chapter 8 and chapter, I think it's 1. And also there's another book here, I'll go into it later, regarding the Hebrew alphabet and how it relates, but you'll understand when I get to it. What I'm going to be proving is why all stars nova. Now, the reason why it's important to you is the next Gleisberg cycle is between September and December 2046. And 136 Gleisberg cycles is 12,068 years. There's about 3 or 4 other, well, actually 5 other cycles of the sun that we know of, I covered in the previous videos, that also hit on the main clock cycle. So, and the Torah actually has an exact month, the day, and the year of October 16th, 2046. So I strongly believe this reversal might happen then, since now the Earth's magnetic field is without question in the process of reversing, and its magnetic field is reversing exponentially. You might pay attention. If you're a young person, you can do the math and you'll know how old you'll be for when this event might happen and maybe when you no longer will exist. So that's how important this video is to all of you. And that's why I spent 2.5 months doing additional research to make sure I really proved it. And hopefully this is going to not run too long, but I'm afraid it might. I'd shown this before. It's a legend, actually, from Plato's Dialogues. And it's to show basically the primitives, or the previous civilizations, the Greek and the Hebrew, knew something bad happened roughly every 12,000 years. And he says, as a reversed action during infinite ages, this new action is spontaneous and is due to exquisite perfection of balance. That's the reversal. To the vast size of the universe and to the smallness of the pivot upon which it turns. Like I estimated, the actual reversal time is about 7 or 8 hours, where the Earth stops its rotation and you get a good view of the sun, let's put it that way. All changes in the heavens affect the animal world, and this, being the greatest of them, is most destructive to man and animals. At the beginning of the cycle before our own, very few of them had survived, and on these a mighty change passed. He's not kidding. It just shows you a lot of civilizations knew this thing was going to happen. In chapter 11 of Reality Revealed, my first book, which is not available other than on CDs, which we sell, Vector Pub sells it for $10. Amazon had a couple for sale for $400 and $1,200, and I looked again. There's only one company that has one available. He wants $48,600 for it. I'm not kidding. Quote from Einstein. This is to show the scientists knew something was wrong with their matter-oriented theory of existence. I must confess that I was unable to find an explanation for the atomic characteristics of nature. One might find a way to avoid the space-time continuum altogether, although I haven't the slightest idea of what kind of elementary concept could be used in such a theory. It's not an element, that's why it's not a particle. It's waveforms and information. And that's where he and everybody else screwed up. It's because they were taught that. And that's, you don't know why you were given this matter theory of existence, but when I do series 12, you'll all know. The problem we're facing is two very different science philosophies. One is a matter-oriented theory of existence, and you look at everything, even as light as particles, and all the subatomic particles, in quotes, are thought of as particles, even though it has no weight. The only other way you could wind up describing the universe is an information theory of existence, which is my theory of multidimensional reality. I'm the first one to develop it, no one before me, and I'm sure there'll be people who will copy it. In fact, the last paper Stephen Hawking had, he actually was admitting that it was a hologram. If you read it carefully, he says that it's a hologram. The only way you can have a hologram is you've got information that creates the hologram. Now, I want everybody, if any scientists are watching this, astronomers, astrophysicists, and physicists, I want you to never forget this, so you understand what's going on and what really happened. This was Bill Casey. He was the head of the CIA at the time of the Reagan administration. And this is the very first meeting they had with Reagan. And this is his quote, accurately quoted. "We'll know our disinformation program is complete when everything the American public believes is false." Barbara Honegger was at the meeting and she reported to a reporter, and that's how the world got known. This is Mr. One World Government himself, a real chip off the old block of Prescott Bush, which was definitely a national socialist, and this guy was equal. And this was his quote. He was CIA director from 76 to 77. "Sarah, if the American people ever find out what we have done, they would chase us down the street and lynch us." He ain't kidding. Now, why did this happen? This all happened, as I explained in, I think it was series 4, when the sun had its Gleisberg cycle in December of 57, early 58, January 58, they were very scared. They didn't know, well, one of the journal articles called, "Is Our Model of the Sun Correct?" And they found that it's not. And shortly thereafter, in 58, they started NASA, and that postage stamp I showed. And it was all one reason, to find evidence, does our sun nova? When they landed on the moon, there's no question, it was absolutely correct. The sun does nova. And this video will prove it. You'll understand the mechanism. You'll understand which mechanisms that have been presented before me, other than mine, are wrong, and the reasons why. It'll become so obvious to you. Okay, first thing, these are the different names I have found for a nova. Micronova, luminous red nova, dwarf nova, transient astronomical event, oh, that's a good one. X-ray transient, hypernova, X-ray burster, gamma ray bursts, soft X-ray transient, cataclysmic variable star, I like that one. By the way, the word cataclysm is derived from the Greek word kataklysmos, which translates to combustion of the earth. Got a hint there? Solar proton event, there's the reference, you could see that one. This is the favorite, Ben Davidson loves this one also. Magnetic springs that periodically go off in the center of the sun. And there's the reference for it. And then finally, planetary nebula. At first they thought planetary nebulas were the premortal period, that the stuff that's supposed to condense and become a star. They finally gave that up and realized this is too stupid for words. And they realized it's a star that had novaed, and that was it. Anyway, I'm going to give you a brief explanation of what the traditional explanations of a nova are, so you understand where they're going with this. Now understand, this is just crap. It's just pure lies. And now you'll understand why from what the CIA directors both said. When all the hydrogen is used up in a sun-like star, it throws off the outer envelopes of a nova and becomes very small, very hot white dwarf. These white dwarfs are the inner cores of the dead stars which have used up all of their available fuel. They believe the core transforms from hydrogen to helium and finally to carbon, but they don't explain the other stages it has to go through, which is helium to lithium, lithium to beryllium, to boron, and then carbon. Now, the only reason they said that is because the spectral line frequencies, they're safe when a star novas, it's got carbon in it, and it's got all the other stuff. But these are the same, also you'll see later, iron too. By the way, iron you can't do fusion or fission with, so I don't know how they got the iron, you know. Maybe they pulled it out of a hat. This is all for one reason. It's to basically salvage physics, nuclear physics. That's what's going on here. That's what happened when the sun went nuts in the Gleisberg cycle. They couldn't explain it, and they knew nuclear physics was in trouble. That and finding no neutrinos, and also the quasars, which I'll go into later. But I want you to get the whole picture, the history of this thing. Okay, so this is what they're trying to describe. That you got a big old star here, and you have a companion white dwarf. And magically, the white dwarf takes matter off of the other star, the companion star. When it gets enough mass here, then the gravity and such, it blows up like that. This is all their theory, to try to rescue and salvage physics. Here's another lovely artist drawing. They've never saw this, but the artist did a wonderful job. Who is it? Harry. Harry did a wonderful job. Now, they hang their hat on one or two things they've seen. NRAO1ADF4b. Not kidding, that's the name. Now, we're going to focus right in this area. Now, in this area, they found this. Star basically nova, October 2013, November. It's pretty close here and stretched out a little bit more. Now, these are radio signals and X-rays and stuff like that. 2015, about a year and 2 years later, they got this. Well, I adjusted in Photoshop. I went from that, well, that earlier picture, to this. I dropped down the brightness, and I wound up seeing really what was going on here. This is the beginning, 2 years later. This is the companion star. This star gave birth to a planet. That's what they're looking at. It's nothing else. You could see it went farther away from here because the stars give birth to the planets. That's why planets circle stars. How do you think the planets got there? They dropped down from midair. They all have an orbit around the planetary plane of the star. How do you think it got there? Santa Claus? That's why some of the stuff, the conclusions are so stupid, I'm amazed. I have PhDs. Here's another example. Sirius A and B, X-ray image. It's 6 light years away, and they see this thing right over here. You're probably looking at another planet that this star created, and that's all. By the way, there isn't enough galactic dust to create a star around it. Okay, super flares on solar-type stars from first-year observation of this. This is a paper submitted and by Chinese scientists, not Americans, because remember, the Americans are more or less locked down to the National Science Foundation. You apply for a grant that's going to point to proving that our sun novas, you don't get the grant money. And these guys don't do the research unless they get the grant money. This is a quote from them. This just released journal article from several Chinese scientists looked at 1,216 super flares on 400 stars and did not find any stars in conjunction with a white dwarf causing the solar flare or novas. In other words, that theory is dead and buried. Ben Davidson had pointed me to this, and we have a number of stars that flare up. And 4 of them had enough observations, so I wanted to see, okay, there was a pattern to any of these things. So this is an image of this one here. And we had quite a few observations. So what I did is the number of years from here to here, 9 years, 26, blah, 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 go through down here, and with a total of 108, divided by the number, and the average was 10.8 years. Our sunspot cycle is 11.09 years, so I'm only about 4 months different. The next star, oh, by the way, this is 10,300 light years away, not exactly in the neighborhood. Here's another one, 39,000, probably let's say 40,000 light years away. Enough observations, it averaged 10.46, about, what, 7 months off from 11.09 years? Not too bad. 9,700 light years, about 10,000 light years away, 5 observations, 12.83. That was the furthest off, a year and 9 months off, but pretty close. One with 3 was pretty good. Average 11.86 years, we're 11.09, only about 8 or 9 months off. What I think by the way, the variables here are this. This was done at Harvard University. They had picture plates of these stars, and they compared the plates for the years that they took pictures. But we don't know if they took the picture exactly on the sunspot maximum for them, or 2 years before, 2 years after. We don't know. They don't know either, because we're only guessing at how many light years away these stars are. But to find 4 that are pretty close, I'd say really, if you find 4 stars that have the sunspot cycle 11.09, you can bet that almost, if not all of them do, because it's a resynchronizing frequency, should be going on all over the universe, which means they all have Gleisberg cycles and they all have everything else, the other cycles. And we don't know whether the other one, the suns really flare off, but it's not a nova, it's just one of the resynchronizing or synchronizing frequencies hit. You have to think in terms of frequencies and information. This is the other explanation for a supernova. Somehow the star gets an iron core, but I don't know how they come up with this, because iron, like I said, is the only one you can't do fusion or fission with, so how do you wind up with an iron core? So anyway, it's got different layers here: silicon, magnesium, neon, oxygen, carbon, helium, hydrogen, as you go further out. And then somehow the gravity pushes in, and the forces of what's going on in the middle push out. Eventually, it squeezes down. This is like the atomic bomb, a hydrogen bomb model is really what they come up with. And eventually it blows, and you got yourself a hydrogen bomb. That's what they're saying. Of course, they don't explain how the iron get here. This is traditional models. Supposedly it all came from the stellar soup, a bunch of dust cells coming from the inside of a quasar or a galaxy, and some of the dust congeals and become an average star like ours, or a big star. And either we become a red giant when we burn up some fuel, or it becomes a supergiant, and then when it novas, it has a planetary nebula, which we'll go into. You'll love this. Or you become a supernova, and this becomes a white dwarf, which doesn't really happen. We already know that. Or this one becomes a neutron star or a black hole. And in this video, I'm going to destroy that one. This one, don't know, don't care about. Remember, this model is for one reason: to save nuclear physics. This is the number of databases there are. I didn't go into the ones that dealt with galaxies. It wasn't what I was looking for. But I went in through all of these and made databases of quite a few of them. These are the ones I have databases for, and how many records are in each one of the databases. And I looked at most of the stars, or open clusters, or globular clusters in each one. So planetary nebula, globular clusters, stars, almost 9,000 of them. This was 469 open clusters. Partial list. This one actually, there's tens of thousands in the list. It's a new list. Mystery objects, 217, novas, dark nebulae. I'm going to go through all of these, and this is how many records in each one. And I had to go through and I will look. There's a lot of duplication also on this stuff. Here's what the database looked like. This was HD stars, just plain stars. There's only one that goes over, or a few that, yeah, there was one that goes over the 12,000 light year cycle. I guess after that, it has to be an open cluster or globular cluster to see it, but actually two of them here. And these are just estimates anyway. I mean, they do the best they can. Triangulation is tough, and they try to use redshift for the different elements and try to guesstimate, to figure out how far away this thing is. But you see there's a lot of different names they go by, the same star. It gets a little confusing. I feel sorry for the astronomers that have to deal with this. But anyway, this is the magnitude, this number, and what they usually give you in kiloparsecs and how many light years away it is, so you get a feel for it. And this is one of them, what it looks like, that falls on one of these, 12,400 light years. And here's another one that's about 13,000 light years, pretty bright. Here's another one, again, stars, what they looked like, and where they were in the constellations. Here's another one, databases. These are stars that have novaed in 2018. These here are interesting to me. This one looks like it was like 48,000 light years when 4 cycles ago. But look what he put here. This is kind of a joke. 999,999 plus or minus 28,000. Now, either that's a flag and saying, okay, I know it's 48,000, 4 cycles back, but I'm going to throw everybody off. But those in the know will know what he's saying. This one's 1 cycle back, 12,000 light years ago, 12,000 years ago to happen, and that's the name of it. This one here probably also 12,000 because it's got a plus or minus 3,600 or a minus 2,100, so it's 12,000 light years ago. That's that one, and this one is 2 cycles ago. Again, he did the 99,999, which is kind of funny to me. What was this one? Oh, globular clusters. You'll see what a globular cluster looks like in a second. But those they can see farther away, but they have them closer also. And a globular cluster could be from 10,000, 5,000 stars up to, I saw 200,000, 300,000, they think, in a very tight area. And magnitude and the diameter is really interesting. Some are very tight, like 6.8 light years across. 90 light years is pretty wide. So in a very tight area, they have a tremendous number. These are all globular clusters. Here's some open ones. There's another database and how many records are in it. And other names that it goes by. So if you want to follow it, try the NGC number if you can't find it in this number here. But the interesting one was, well, some of these, you have almost all the cycles. That was what the ones in yellow I highlighted here. And you'll be able to see that because it's a lot of stars in one area. Another one, globular clusters. Again, same type of thing. Another database of globular clusters and their numbers. That's what the one looks like. Very tight, 50, 100,000 stars in a very tight area. I blew it up so you see what it looks like. When you blow it up, I have to drop down the light intensity. You can actually see the points. Here's some other examples. This is roughly 25,000 light years away. By the way, I've seen some numbers that it could be as much as 30% off. So they really have a tough time trying to figure out how far away these things are. This would be 3 cycles back. A lot. Now, the ones that are red in here may be ones that are in active nova when they took the picture. black and white one, unfortunately, 13,000 light years away, and this is 24. And you can see how tight they are. Now, the first thing you have to ask yourself is, why do these things exist in a galaxy? Why? Now, I did this timeline thing. Imagine we're off there and we're looking this way. These represent a 12,068 year timeline as it goes through time. Every time a star falls on this thing, it'll hit nova. If it's a small star like ours, you may blink out because the dust shell will conceal the light from it. If it's a big star, that doesn't happen as much. So that's what I'm saying. In reality, we're in front of this thing and we're looking back at it, and that's what's really going on here. And this actually fell right on one of the timelines. But again, there's an error in this thing, but we don't know how much. Okay, why do these things exist at all? Because if you're in one of these things and they're like 4 or 5 light years apart, I don't understand, if you're on a planet and a star in that, it would never get dark. You'd have stars all around you. You couldn't have missed it. And also, if one novaed and they all start novaing within days or weeks of itself or years, I got news for you, you're not going to survive it either. So I don't think there's any life on some of these things inside a globular cluster. But this is what the astronomers put together. This is 31 million light years across. And this is the model. These are galaxies. And these are bright spots in the galaxies. I have a feeling that, now this is a map, the Germans did this on a map of the brain cells, and this is also a map of brain cells. And you'll notice with the brain cells, you have nodes that do processing. My conjecture or theory that maybe those globular clusters are really doing processing for information going to them or through them and directed to someplace else, like a router. But it's a tremendous amount of information. But other than that, you have to explain philosophically why there's supposedly about 150 globular clusters in our Milky Way. Why was it created? More globular clusters, 469 records of this stuff, open clusters and globular clusters. Had both of them in the database, like some of the others do. You can't separate them, but this is what how many there were that were around the dates that I'm looking for. Miser group, 217 of open clusters, again, and globular clusters, but again, a lot of duplication. NGC list, I only saved the ones that were open clusters and globular clusters. The rest is mostly galaxies, a lot of galaxies. Okay, here's what an open cluster looks like. Not as many stars, could be 30, 50, could be 1,000. Here's a picture of one. The only thing I'm kind of leery about with labeling an open cluster is that you don't know if this star is 30 light years in front of you and this one's 80 or 90 light years behind it, and that goes for the rest of them in this area. So you really don't know, because of your vantage point, it looks like there's a grouping, but there really isn't. The globular cluster is another story. That's pretty obvious. Planetary nebula. Now we get to the good stuff. They finally admit a globular cluster is a star that has novaed and thrown off its dust shell around it. And this is how many fall in this range that I was looking for. The database had a lot, 173 of them. It's estimated there's a lot more than that. I think it was like 1,200. Again, focus on this and the shape of it and the way it looks. Now, keep in mind, if their model of a star was correct, that it's hydrogen, burns to helium, and does all the stuff, and they all have the same chemical composition, then what you're going to see is, ask yourself, why don't they all look alike or similar? And they don't. Okay, this is another thing done by the Japanese. Now, for those who think that novas are pretty rare, doesn't happen too often, you're going to find out different. What they did was, in a very narrow spectrum, only 1.77 degrees of arc, and a depth of 5.78 degrees, over 4 to 6 months, in 16 and 17, they found 1,824, they call them supernovas. I added nova to this. And what they had was an extremely sensitive CCD, which measures light intensity. And they put it on a telescope. This is the before, then after, and the difference. This registers the difference. And they literally have 1,800. If you go onto the website on theirs, they actually have that many pictures of them all. This is another one. Catalog of integrated H-alpha fluxes for 1,258 galactic planetary nebulae, stars that have nova. The green dots, I had to highlight these things. They made a mistake when they made it with a zero or a round donut, and it doesn't show up too good, so I had to highlight all of them. And this is who did it. The green ones are things that they researched with their instruments, and the red ones were from the journals, other people's work. Now, this is the galactic plane. One of the theories is that when you a star crosses the galactic plane, that magically the electrostatic field coming out of this thing winds up affecting the star to flare up or micronova or fill in the blanks, you know? We have a whole bunch of stars here and here that will never cross the galactic plane, ever. But they all know of it. Now the other part, so that theory should be put to bed. I'll be kind. Now, the other thing you should learn from this, from that traditional graph of what a star is and what it goes through, if supposedly there's a black hole in the middle of a galaxy. Now, black hole is supposed to only happen after a real big star, collapses down and burns everything up, and it becomes a black hole, courtesy of Stephen Hawking. Then how come I have a whole bunch of stars in the middle of this thing that have nova? You can't even explain how the black hole got there to begin with. Are they trying to say that a big star, supernovaed, became a black hole, and all these stars, billions of stars, came out of it by sheer magic? It's just unbelievable. In that respect, the logic is beyond stupid. This is the other part that's stupid. I mean, this proves that all stars nova. They could be brand new, 12,000, when that clock cycle hits, it'll nova. It's going to throw out whatever mass or matter it's created. That's what this is showing. This is a picture of the plot of the magnetic field of our galaxy. Anyway, on that picture, the spectral distribution of PN's possible novas overlaid on a grayscale H-alpha map of the southern galactic plane generated from SHA-SSA data. The top panel is, well, I'll go through it. Basically, it's this work they did in the green cycles and the red ones for other people, which I just stated. So, dark nebula. Remember I mentioned Bach globulars in Series 1 on how I found the clock cycle, but this is what it looks like. Good picture of it. Each one of these is a star that novaed through a dust shell, probably a star the size of the Earth, and the size of our sun. Here's another group in color. They didn't have any distances, but Bach, the astronomer Bach, had 450 listed. This database was 344, and it was from 11,500 light years to about 13,000 light years of what they estimated by triangulation. That's how many he recorded. They didn't give us any distance whatsoever. But globulars then changed the name. They call it now dark nebula. Again, a star that nova. This is what they look like. Now, there's two things to note here. This is the globulars. The darker areas are stars that nova, but you don't see any stars behind it showing through. But this is wall-to-wall stars. Now, I blew this area up. I think it was in here, and you'll see it in a second. That was that area blown up. These white dots and red dots are all stars. I blew this area up right here. These stars are in the state of, I think, nova. All the rest is all stars. It's wall-to-wall stars. They're literally billions. The job the astronomers have are, I give them a lot of credit. This is an endless job. You'd never end doing this stuff. Here's more of them. Dark nebula and Bach globulars. Here's a black and white photo. It's in here. Nothing, no light passed through. Here. These are all obviously done. They happen at the time of the reversal. And the small stars in there, nova conceals their location. The dust is there, and you can't see the stars behind it. What's this one? This is, okay, this is VIII Monocritoceroteus. I'm just going to call it VIII. This is what the star before it nova. 1989, normal star, no problem, another dot in the sky. Then it erupted, I think it was more like February it erupted, and they picked it up, U.S. Naval Observatory, or shortly after the nova, in 2002. I'm going to go through the whole thing. Now, I read all the journal, almost all the journals that were trying to describe this thing and the distance, and it comes out, it was 2 cycles back, 25,000 light years ago, or 25,000 years ago, this thing happened, and we just saw the light in 2002. So this is May of 2002, a few months later. There, look, try to memorize these shapes. September 2002, see this nice little dust cloud? See the openings here? You'll see it get bigger. Then you got fancy, you have a composite picture here. This is a combination of infrared, ultraviolet, and I think maybe X-ray. And they make a composite, get all these nice, cute colors. And this is in May of 2002. September 2nd, my birthday, 2002. See the same holes here? Just getting bigger. There. October 2002. December 2002. Dust shell obviously going out. This is 2005, it's November, and this is September 2006. And the dust shell kind of amorphously blending out to someplace. Same thing here. You couldn't even recognize it was a round ball originally. Now, this is a paper that was given at AAS meeting 2002. This is when the thing, January 2002, when the thing, this is just before I think VIII had novaed or they noticed it. The point being is, they glommed onto this guy's observation or theory of something that a nova that happened in 1998. And I'll read the thing. We resolved that the light echoes produced by the Type 1a supernova in 1998 BU using the Hubble Space Telescope, wide field, blah, blah, blah. An echo resulted when light emitted near supernova maximum is redirected towards the Earth by dust scattering and delayed by the increased path length. Now, the other maximum is, supernova maximum is usually only about a year and a half, tops. Not spread over 5 years. SN 1987A and SN 1991T are the only other supernova to have detected echoes. Supernova 1998 is in M96 is a galaxy, get this, 31 million light years away. There's no way you could see any kind of dust around anything. You couldn't see dust around a star that's 12,000 light years away, more or less 31 million. This guy was just shooting at the hip, came up with a theory, make himself famous. The light echo in V838 by this guy, Astronomy and Astrophysics. This is in the article. This is his conclusion, though. The nature of the eruption is enigmatic. It cannot be accounted for by known thermonuclear events. This is where V838 is above the galactic plane. Here's our sun, center of the galaxy. Oh, gee, white spot. I don't see any black hole there, do you? Okay, this is what he's thinking, what he theorizes, that magically the dust is like the shape of a parabolic mirror, and the light hits there and then comes to us and we see the shadow. This is beyond bullshit. This is flagrant, colossal lies that they're feeding you so you don't think that stars nova. That's the reason they're doing this. Okay. No dust shell around V838. Remember, the thing's 24,000 light years. I don't see any dust around this thing. Do you? They didn't either. It's just pure crap. Okay. Now, I want you to pay attention to two things. All the different shapes of all these novas. All these stars nova. Now, I've got a picture. This is V838. I'm going to leave it here for you to compare. Now, you'll also notice they're all different. Again, remember, think, if supposedly the stars are all made up exactly the same, and they're all exactly the same, why do they all look different? And I saw hundreds of these things. Here's more of them. Look. They're all different, but have basically the same kind of a shape, depending on when we're seeing this happen. Here's a green one from my Irish relatives. My grandmother was Irish on my father's side. Here's another greenie. But you'll see, there's the star that nova. Gee, it didn't become a black hole at all, did it? How do you like that? They're all there. Isn't that amazing? I try to put the light year, how many light years it is if they gave it. Some very interesting shapes. Look. Another one there. 55,000 light years away. This is pretty. I like that one. More. Basically, a dust shell blown out. There's the star still there. V838, the star's still there. And you have this big dust shell. Now, this is the one that was in 2006. Planetary nebula, where its dust shell expanded out also. Look. See? Look at that. And the star's in there. There's the star there. Someplace in there, God knows. Here's more. There's the star. It kind of spread out. This one's pretty. I think that was cat's eye. This one, that. Now, some of many of these with multiple colors are composite pictures of infrared, ultraviolet. They photograph regular light, and then they may throw an X-ray or radio also. And they give it different color values for the data, and then they superimpose them on one. So that's why this all looks that way. So a regular telescope is not going to look as pretty as that. More. See? Now, by the way, there's a reason why it's brighter here and here. Its planetary plane is probably along here, and this is electrostatic field gone up. This is probably a radio telescope photographed this, and they put the values in. Same thing here. There's the star. There's the star. There's the star. Okay. They knew the timeline for this thing was, this thing happened 24,000 some odd light years ago, and they had to cover that up. And they did everything they possibly could, including that incredibly stupid explanation of a light echo. Okay, sometimes the truth is staring you in the face, and sometimes you don't see it, or in some cases, you don't want to see it, especially if if you want grant money from the National Science Foundation, you definitely don't want to see it. So anyway, they're all different because they are different. They're not burning fuel inside. They're hitting a clock cycle. What's the center of all stars, like the center of the Earth, even the center of an atom, is a center modulation point where a lot of frequencies and information is being directed to a point in time and space. When these clock cycles hit, if it's a sunspot cycle, there's a rise in output. It gets brighter. Some of the others get a lot brighter. During the clock cycle, all the synchronizing and resynchronizing frequencies are all geared to the main clock cycle. When that goes, you have the nova. And that's what you're dealing with, that's what you're looking at. So why are they all different? They're different because just like you and me and everybody else is different. I mean, we have the shape of a human, all the body parts, but we're still very different. And just like they are. Remember, if you go back to Series 1 when I defined dimensions, I'm right. The difference between like the fourth to a fifth dimension is an exponential increase. From sixth to seventh is a planet. It's a tremendous exponential increase in the amount of information it contains, it can control, and again, the light is a function of the information that makes it up. And then finally a star, exponential increase between a planet and a star. That's because it's an information theory of existence. This is a created reality, whether any of us like it or not. That's what this is, and that's why they're all novaing exactly the same time. This drama is happening all over the universe at the exact same time. Supernova explosions driven by, this is a funny line from one of the journals. This is from, who quoted this? Oh, him, Knert. A supernova explosion driven by magnetic springs. A few scientists have theorized magnetic springs periodically go off in the center of a star, and this mechanism would explain the tremendous dust shell vicinity observed. I've already given the geological evidence, physical evidence that the sun novas, the glass beads and everything else, and the radioactive elements. So I cover that in Series 1, and in Series 4 is on the physical evidence that the sun does nova and what happens on the Earth. I shouldn't even have to go into it, but those who are seeing this for the first time, go see those two series, you should. Now, how about our sun? Does our sun nova? This is the third rail for the CIA. They don't, and NASA. They don't want you to know this. But again, the truth is obvious. It's staring you in the face. Here's a nebula, star that nova. Now it blows out top and bottom, and this could be like big dust shells around it. This is even better. Oh, this is their planetary plane. This is the planetary plane. You can see it here, little dust here. You can see this darker area in here. That's where its planets would be. This is another one, supernova 1987A. Now, it's funny, 169,000 light years comes out to exactly 12,068 light years ago. It blew right on one of the timelines. Here's this planetary plane, and the electrostatic field went up and down like here also. Now, does our sun nova? Just like planetary plane, planetary plane, planetary plane. This is the Kuiper belt. Gee. They found this from, I think, Voyager 2, and I think it was 84. And when I heard it, I knew they turned on the camera when the thing was going through the thing, and they knew what they were looking for. It's almost as if they read my first book to look for it. And they found it. There it is. There's the remnants from the nova, but not all of it. This is what an artist came up with for what's in the Kuiper belt. It can't be too big a rock, so that Voyager 2 would have been destroyed going through it. It's probably those little glass beads and dust and stuff like that, but I don't think very big. Japanese did a good job. They did find bigger products and objects in the Kuiper Belt, and here it is. There's Jupiter, Saturn, Uranus, and Neptune. It's in this area, but they found some other stuff in here too. So there it is. That's the physical evidence it exists. This is, now the next is an Oort cloud. This is the planetary plane, the Kuiper Belt. Now it's theorized that, this is from the European Space Agency, that there's a dust shell around our sun. Gee, I wonder where they got that idea from. Oh yeah, since they saw all the other stars that nova have a dust shell like that, they knew it was going to be there. Here's a lovely drawing. Eagle source, I think it is. Here's the Oort cloud. Here's the planetary nebula, the Kuiper Belt, and here's the sun. This is from NASA. Again, the Oort cloud, planetary equator, and that's it. I mean, so if A is equal to B, B is equal to C. If all those stars have a dust shell around it and a planetary plane, and they admit they know it novaed, and our sun has a planetary plane, the Kuiper Belt, the dust, and it has a big, we think, an Oort cloud around it, which is the remnant dust shell, then I'd say our sun does nova. Wouldn't you? I think the evidence is pretty obvious and pretty plain. This should settle once and for all. It's not a micronova, it's not a mere nova. It is a real nova, like all the other stars are going to go through. Ours does too. That's what causes all that evaporation of the oceans to have an ice field from 4,000 or 5,000, 3,000 feet thick. Now, quasars. I'm almost done with this. I don't want to go too long. Quasars are the beginning of a galaxy. All stars form from the center of a galaxy. Supposedly all galaxies have a black hole in the center. The only black hole existed was between the ears of Stephen Hawking. Gifted mathematician, lousy philosopher. This is an artist's drawing, obviously, because I've seen hundreds, if not now maybe 1,000 galaxies, and I got news for you. Never saw a black thing in the middle of this thing at all. It all shined brightly. Okay, now I'm going to destroy it with the next few videos, the next few screenshots. You'll see it right off the bat. Here's pictures of real quasars. This is radio telescope stuff or X-rays. This is what the artist drew here, not where the stars and the dust is being created. But you notice he's no arms here. He has it just even throughout the whole thing. They want you to believe that. It's not true. Okay, here's another quasar. And here's this jet, which probably is the same as this. Now here's quasars. Something in the center is doing it. And out of the center, you have two arms of stars coming out. Now you'll notice it's 180 degrees from each other, and here's the center. Here's another quasar. And here's the radio noise part. And they focused on this, and here's your galactic ring, where it's creating the matter. I don't think this is an artist's drawing, but a composite. They didn't say it was an artist's drawing, but here's the electrostatic field, and here's the galactic plane where all the stars are. Here's another picture of one. Now it's galaxies. I want you to see two things. All have two arms, 180 degrees opposite each other. See? This one's coming from here, going there, two arms. Or streams or jet streams. Again, same thing here. All 180 degrees coming out from the center. 180 degrees opposite each other. Same here, here. This is real obvious. There and there. Here and there. Here and there. Two arms opposite each other, coming out of a center point 180 degrees from each other. This is real visible. M83, look at that. No question about it. Here's another one, I didn't get the number off of it. Again, this one starts here, this one starts here. 180 degrees off of each other. Same thing here. Obvious here too. This is the numbers for them, M61. This is their model for a black hole. Again, that nasty toroid shows up. Isn't that interesting? Mathematically, this is how they describe it, as a toroid. The black line here is singularity, and this is the outer parts of the event horizon stuff. And this is how they describe a galaxy. A lot of dust, clumpy gas and dust torus around a black hole and whatever this is here, what they describe here. What do they call it? Acceleration disk. That's interesting. They know it. They know the center of a galaxy is rotating. They just don't know why. Now you're going to get the explanation. Here's a galaxy. Again, the radio telescope picked these things up, and then here's the galactic plane across here. Again, 90 degrees out of phase from each other. This lovely drawing was done to describe the Earth's magnetic field. The Earth was here, and this is the center of the Earth, and it creates a magnetic field around here. But I could use this same model for the model of the atom, which I used in Series 1, or the sun, or a galaxy. It's no difference. This is energy coming 90 degrees out of phase from where it creates the matter. It creates the matter here, and the electrostatic and magnetic fields are this way. This is my famous graph. You understand this graph, you understand how the universe really works. What is true for the microscopic, the atom, is true for the macroscopic, a galaxy, quasar, doesn't matter. This is the information dimension. When it crosses the x-axis, it creates a spike, and the atom I identified as what they call Planck's constant, which is really electrostatic field contained by a magnetic field, which is information. And you notice they're opposite each other. How do you like that? Now, Hebrew alphabet stuff, I use this picture. Same thing. When it crossed the x-axis, the people who, here's your x-axis, across it is this. The ones who created the Hebrew alphabet made a letter. Every time it crossed the x-axis, they made a letter out of it. Now, here's our little model. It's the same. Toroid, toroid. Same thing. Now, why are these two jets 180 degrees off from each other? There's no black hole here, because they'd have to explain where the black hole come from. If it was a star, a huge star that became a black hole, does it have enough mass to actually create billions of stars later? And it fails right there. You don't have to go any further than that. Here's the Hebrew alphabet. Now, what do you notice? It creates matter there, when it crossed the x-axis, and created matter there for the atom. That's where it's creating it, there and there. Gee, 180 degrees off from each other. How do you like that? Now, for those of you who are atheists, or I should say more or less an astronomer who's been thoroughly trained in what you've been taught over the last 40 or 60 years, please remember The CIA and the federal government and NASA did everything they could to make sure what you were taught would not lead you to understanding this, why our star and all stars nova. They did everything they could. Of course, technology and observation has outstripped their ability to lie to you. And that's what some of this stuff really is. It's outright lies. And it's a shame. But that's the only thing I can say about it is that's what I'm looking at and what I'm seeing. So what's happening in the center of the galaxy is what? Evidently, the dihole, the thing that creates our reality, opens up a toroid shape. And it basically, like a tear in reality, and it pours out stars in two different directions. Whole stars. There's no black hole there. It opens it up and pours out information that becomes these stars. Where did the dust come from this stuff? Every 12,068 years the clock cycle goes, and that star will throw up its mass shell, its matter shell, and hey, guess what? You got dust. And you saw the dust found on the moon and on the Earth. Hey, and also on Mars too. Closing shot. Thomas Gold, 1969, was the first to suggest that a flash from the sun could have explained all the observations he saw of samples and pictures from the moon, including rocks with a glaze mainly on the top. He went as far as to write, "The phenomena may not be in the nature of a flare, but in the nature of a very minor nova-like outburst of the sun." There's the reference if you want to check it. He also did some other papers after that, and his reward from NASA was they cut him from this contract. They ended it. He was too embarrassing because he was too honest. My suggestion to the astrophysicists and physicists that know some of this stuff, because I know some did, remember I showed you Ken Kuzman's letter. Well, guess what? It's time for you to come clean. If you know something, tell people. If this thing's going to happen in 26 years and a few months, your children, your grandchildren are not going to survive this unless you tell people and force government to do something. Otherwise, you don't have a gnat's ass chance in hell. Dihole Foundation is a 501c3, a science foundation. You can guess what we study. And the money and grant money we get, contributions we've gotten, we appreciate it. It helps us do these videos and also further research and stuff like that. I'd like to get enough money to hire a geologist or some other geology students to do additional work and research to help prove to people that this thing happens. It's going to take at least 10 to 50% of the population of the United States to know this thing's going to happen, to force government to do something or at least investigate. That's it. I hope you learned something from this, and you now know what a nova is, and they all stars nova.